Question number 7. Use the substitution x equals to tan theta to show that this integral is equals to this integral. Okay, so let's start. Okay, let's replace the x here with tan first. So integration of 1 minus tan square theta over 1 plus tan square theta whole squared. Okay. We will also have to replace dx by some d theta term. How do we do that? We start from the given substitution. We're given x equals tan theta. Okay. Derivate both sides with respect to x. So derivate with respect to x. So we get a 1 equals derivative of tan theta is secant square theta. But with it, we'll also write d theta by dx because we're substituting with respect to x, just like we do in implicit equations in the topic of differentiation. Okay. Now move the dx to the other side and we can see that dx is equals to secant squared theta d theta. So instead of this dx, I will not write dx here. Instead, I'll write secant squared theta d theta. All right. Now, notice that from trigonometry, we know 1 plus tan square theta is actually secant square theta. So we have a secant square theta whole squared in the denominator. So we have secant 4 theta. And here we have a secant square theta. So they cancel out and we get a secant square theta in the denominator. Okay. So now we will be splitting the numerator into two parts. Splitting the fraction into two parts, 1 over secant square theta minus, there's an integral sign here, okay, minus tan square theta over secant square theta. Okay, so secant square theta can go to the numerator and become cos square theta minus this secant square theta can also go in the numerator, become a cos square theta. Along with it, we have a tan square theta, which is sine square theta over cos square theta. So after cancellation, we're left with cos square theta minus sine square theta. And again, from trigonometric identities, which are also given in the formula sheet, we know that cos square theta minus sine square theta is also equals to cos 2 theta. So we have derived the required result. Okay. Part 2 says, hence find the integration of this within the limits 1 to 0. All right. So before we start, the first thing we need to do is convert these values of x. X is 0 and 1 on the integration limits. We're going to change these into thetas and use those limits here and here. So when x is 0, that means from this 0 is equals to tan theta and theta will be equals to tan inverse 0, which is 0. So theta is also 0. When x is 0, theta is 0. And when x is 1, then we get 1 equals tan theta. Then we take tan inverse of 1, which is pi by 4. So when x is 1, theta is pi by 4. So we're going to integrate cos 2 theta d theta within the limits 0 to pi by 4. Okay. Now we know that integration of cos x, this is given in the formula sheet by the way, is just sine x. But this is not just cos x, it is cos of 2 theta. So we have a function here. So integration of cos fx would be sine fx upon 2. So this becomes, sorry, sine fx over f prime x, the derivative of it. So integration of cos 2 theta will be equals to sine 2 theta upon 2. So we'll write sine 2 theta upon 2 and the limits are pi by 4 and 0. Now let's substitute the limits. We'll substitute pi by 4, then we'll substitute 0. In fact, when we substitute 0, we get sine 0 upon 2, which is just 0. And now we're going to substitute pi by 4. So we get sine 2 times pi by 4, which is pi by 2. Okay. What is sine pi by 2? I believe it's 1. Let's check. Yes, it is 1. So we get 1 over 2. And that would be the final answer.